Good morning, sir.
Good morning. Do you have any doubt in last class? Last class?
স্যার ওইটা বলবেন বলেছিলেন না আপনি ইম্পালস ইনভেরিয়েন্ট
আমরা বলে দেবো।
বলে
আর তা ওই লাস্ট ক্লাস যেটা পড়েছিলাম সেটা ডাউট আছে কোনো?
হ্যাঁ স্যার
নো ডাউট তো? তা আগে আমি একটু পড়ে নিই, তারপরে আমি বাকিটা ওইটা বলে দিচ্ছি, ঠিক আছে? Okay, so last class what we have discussed, probably if you know remember, all right, okay. So last class what we have discussed regarding bilinear transformation. Bilinear transformation we have started, right? So bilinear transformation, in this we have seen the bilinear transformation S equal to 1 minus Z inverse by 1 plus Z inverse multiplied by 2 by T. That means SYZ will be transformed into 2 by T 1 minus Z inverse by 1 plus Z inverse multiplied by YZ, which means S equal to this, right? That we have discussed. Now, in this regard, we have also discussed that how different poles that are lying in S plane that will be mapped into Z plane. For stable system in analog domain, the poles have to lie in the left half S plane.
yes. Yes.
And for unstable system, poles has to lie right half S plane. This is corresponds to analog domain, right? Now, if I talk of digital domain, in which we will be using Z transform, then the left half S plane poles, they will be mapped into within unit circle or inside the unit circle. So left half S plane pole and right half S plane pole, that will be mapped outside the unit circle. Therefore, from the location of the pole of a transfer function Az, which is in the digital domain. Hello?
হ্যাঁ স্যার বলছি আগের দিনে লাস্টের পোরশনটা একটু বলবেন না?
ওকে আগের দিনটাই বলছি আমি বলছি। So the location of poles in the jet plane that will decide the stability of the system, and the condition is the poles has to lie within the unit circle. Okay. Now, when we talk of bilinear transformation, which we have derived last class, in that we have seen this is the formulation of bilinear transformation. Then if we transform all these things, we will get the value of Z like this. Then if I substitute S equal to sigma I plus j omega I, then I will get Z equal to this. And if I take the magnitude, I will get like this. Now, for left of S plane poles, this sigma I is negative. When this sigma I is negative, then your denominator becomes more compared to numerator, which means that magnitude Zi, which will be less than 1. In other words, that left half S plane pole are mapped into or within unit circle, because magnitude Zi, that will be less than 1. Is it clear? Is it clear? Very good. Now, if sigma I, the real part of S, if that is greater than 0, which means poles are in the right half S plane. If poles are in the right half S plane, then numerator will be greater than the denominator, which means magnitude Zi, that will be greater than 1, which means the poles are lying the outside the unit circle. Essentially, the magnitude Zi is nothing but the radius of the circle in the jet plane. Agreed? Z equal to R into power j omega. magnitude Zi equal to R. Therefore, the magnitude Zi, that actually means the radius of the circle. Okay, so magnitude Zi greater than 1, which means that poles are locating outside the unit circle. Now, when sigma equal to 0, for poles are in the imaginary axis, in the this, because sigma equal to 0, poles are in the imaginary, maybe here, maybe here, maybe here. But in such a case, when this is equal to 0, this part is 0. So this is 1 plus this one, and this is also 1 plus this one. So this is equal to, ratio will be 1, because both numerator and denominator will be same, and therefore this is equal to 1. And if this is equal to 1, am I audible? Is all right?
Yes, sir.
Yes, sir.
So if this is equal to 1, then the poles are lying on the unit circle. So these are all possible cases correspond to mapping of a plane to jet plane. So in summarization, what I say that the poles locating in the left half S plane, they will be within unit circle on the j omega axis on the unit circle, and located right half S plane, that will be outside the unit circle. These are the things what we have discussed yesterday, and up to that I have also sent you the notes, if I'm not wrong. Okay, next,
বলছি
বলো।
ওই আগের নোটটার সেকেন্ড পেজে জন্য একটু প্রবলেম ছিল, যেটা বলছিলাম স্যার ও সেকেন্ড পেজ।
বলো বলো, কি প্রবলেম? বলো বলো।
উপরে যান, সেকেন্ড পেজে যান।
হ্যাঁ, এটা হ্যাঁ
ফ্রম ইকুয়েশন 2 and 3 ওই s equal to ওটা কোথা থেকে এলো?
s equal to এটা কি করে পেলাম? ইকুয়েশন 2 and 3 কি করে হবে? 2টা কি আছে? 2টা এটা আর 3টা এটা। তাহলে দেখো xz xs yz ys, তাহলে ys এর কোএফিসিয়েন্ট হচ্ছে s, yz এর কোএফিসিয়েন্ট হচ্ছে this, তাহলে s equal to this.
আচ্ছা,
Agreed? All right.
yes.
Yes, anyway, very good question. Indeed, very good question indeed. I hope others should have understood this, but anyway, this is a very good question. Anyway, now continuing the previous thing. Now let us assume if the s equal to 0, s equal to, I mean sigma equal to 0, then s equal to sigma plus j omega. If sigma equal to 0, then s becomes j omega. Then magnitude of z equal to 1. Therefore, I can write z equal to e power j omega. Do you agree with that? What I mean that if s equal to j omega corresponding to sigma equal to 0, then sigma equal to 0, then magnitude of z equal to 1 that we have derived in the previous class or previous, just now I have explained. Agreed? Now, if z equal to 1, then in general, magnitude z equal to 1, what does it mean? It means that z equal to e power j omega, right? Because magnitude equal to 1, angle equal to omega. And basically the magnitude of z, that denotes the radius of the circle in the jet plane. Agreed?
Yes.
Very good. Now, corresponding to sigma equal to 0, s equal to j omega and z equal to e power j omega, then if I write s equal to, again we have seen that s equal to 2 by t 1 minus z inverse 1 plus z inverse, already we have derived. This is the relation of s to z mapping using bilinear transformation. Now, if I substitute s equal to j omega, then j omega equal to 2 by t z inverse 1 plus z inverse. Z inverse means e power minus j omega. I am writing e power minus j omega. Then if I take e power minus j omega by 2 common, it will be j omega by 2 minus e power minus j omega by 2. And again in the denominator, it will be e power minus j omega by 2 multiplied by e power j omega by 2 plus e power minus j omega by 2. Is this step okay?
Yes.
Very good. Very good. Now, therefore, what we can see that j omega equal to 2 by t twice j times sine omega by 2 divided by 2 cos omega by 2, because e power minus j omega by 2 minus e power minus j omega by 2, This is equal to 2j sine omega by 2. And e plot j omega by 2 plus e power minus j omega by 2, that is 2 cos omega by 2. This is equal to j times 2 by t tan omega by 2. Is it all right? Is it all right?
Yes, sir.
Very good. Therefore, if I now equate the imaginary part, what I will get? Capital omega is equal to 2 by t tan of omega by 2. This will relate the analog frequency omega to the digital frequency omega. So this is the relationship between analog to digital frequency mapping. Previously, what we did, we have seen that with this transformation, the location of left of S-plane poles, if originally the poles are located in left of S-plane in the analog domain system, then what we have seen, the corresponding poles in the Z domain within the unit circle. Therefore, if the system remains stable in S domain, it will remain stable in Z domain as well. Agreed? Now, I am trying to relation between analog frequency to digital frequency. Suppose if I want to map analog frequency to digital frequency, then what is the relationship using bilinear transformation? Previously, we did this for impulse invariant transformation. Now, we are trying to find a relationship between analog frequency omega with the digital frequency omega. Analog frequency we write capital omega, and digital frequency we are writing small omega. Now, this is the relationship of analog and digital frequency in bilinear transformation or using bilinear transformation. Agreed?
Yes.
Very good. Now, tan omega by 2, I can write omega, capital omega into t by 2. Then I write omega equal to 2 tan inverse omega t by 2. Now, analog frequency omega, what is the minimum value of analog frequency omega? It will be minus infinity. Is not it? Your digital frequency varies 0 to 2 pi or minus pi to pi, because discrete time Fourier transformation is a continuous function of digital frequency and periodic with period 2 pi, which you have learned several times earlier. So therefore, your digital frequency, limit of digital frequency 0 to 2 pi, or we can write minus pi to pi. Nothing beyond that, because other than this 2 pi interval, your x of omega dtft will be periodic, means this will be repeated other than this. Suppose say minus pi to pi, what is the x of a power j omega? That will be repeated all through the spectrum. All other values of this. Minus pi to pi, that will be repeated again, pi to 2 pi, pi to 3 pi, like that. So this will be 2 pi will be the interval over which signal will be repeating. That is called periodicity, right? Or time period, and reciprocal of that equal to frequency, or 2 pi by t equal to frequency. My point is that digital frequency range of vision will be either 0 to pi or minus pi to pi. Okay. Now, if I substitute omega equal to minus infinity, so this will be tan inverse minus infinity. That will be minus pi by 2. Minus pi by 2 multiplied by 2, that corresponding to omega equal to minus pi. And when it equal to omega equal to infinity, so this will be equal to pi by 2, then it will be pi. So when capital omega is equal to minus infinity, omega equal to minus pi, capital omega equal to plus infinity, omega equal to plus pi. Therefore, if analog frequency varying from minus infinity to plus infinity, corresponding variation in digital frequency, that will be minus pi to pi. Agreed?
Yes, sir.
Any doubt? Anybody having any doubt? Careful. Is it okay?
Sir.
ঠিক আছে?
Yes, sir. হ্যাঁ,
বাকি
sir.
সবাই বুঝতে পারছে? All right. Okay. So if you have understood, then it's all right. Then bilinear transformation is over. If you have any doubt, you can ask. Otherwise, I will solve problem. So if you have no answer, means I will assume you have understood. All right. Now,
Yes, sir.
HS equal to this. Suppose I have to convert this into digital transfer function. HS is given. I have to find the HZ. What I have to do? I have to substitute. The HS is this. Your S equal to this. S equal to this. I am substituting S equal to this here. So I will get this expression means S square means this square. 3 into S means this plus 2. Similarly, I will get this. Similarly, I will get this. There is simplification, right? We can simplify this. Once you simplify this, you will get this expression. I have not substituted t because I can substitute t even early also, but I will substitute later part. So after whole derivation, you will substitute t equal to 1 second. Then you will get this expression. This will be your S to Z transformation. I hope this is very straightforward and very simple. If you have any doubt, you can ask. Otherwise, I will revise for the first section, impulse invariant transform for K-Apple, not discuss, attended that class. If you have any doubt, you can ask. Otherwise, I will go to that discussion. Shall I go there?
Yes.
Okay, impulse invariant transform, which you are absent, lucky late. Impulse invariant transform. Impulse invariant transform. কত পাতায় আছে বলো তো ওটা? আমার নোটসে কত পাতায় আছে?
8 মনে হচ্ছে।
8. Yes, this is impulse invariant transformation. So those who have missed this class, let me repeat. A small time, probably 10 minutes left, 10-15 minutes left I have. So let me revise those things. Like if I have HT, it's the impulse response in time domain, analog time domain, then corresponding HS equal to I equal to 1 to n AI plus S plus PI, right? AI plus S plus PI. Any transformation you can write like this. Most of the transformations. Sometimes you cannot write, then you whole square something, that case you will deal them separately. Now suppose if my HS is in the form of I equal to 1 to n AI plus 1 AI by S plus PI. What does it mean? It will be A1 plus S plus P1, A2 by plus S plus P2, A3 by S plus P3, and so on up to n terms. Right? Now, if I find HT, it will be like this. Because inverse of this equal to e power minus P1 of t ut like that. Now, Hn being the filter response in digital domain. So what I have to do? I have to write t equal to nt. So Hn equal to ht, t equal to nt, h of nt. So this will be equal to, you will replace t by nt, you will get this expression. Once I get this expression, it will be a function of n. When something is a function of n, it becomes discrete or digital. Therefore, if I have a digital signal or discrete time signal, I can find Z transform. If you find Z transform, then this will be like this for different kind of Z transform. This term, because a into this power a1 is a constant, e power p and t, e power p into t is your common ratio. So this will be 1 by 1 minus e to the power p on t in Z inverse, so on and so forth. Now, Hz becomes like this. Now, if I write a summation, it will be I equal to 1 to n ai plus 1 plus e to the power pi t into Z inverse. Now, what happened if you look at S plus pi? Now, if you compare 1 and 2, 1 and 2 means this expression, and this expression. If you compare, then you will get this S plus pi is transformed into 1 plus e to the power minus Z pi into this. Okay, is it all right?
Yes, sir.
Very good. Then for poles, what is there? S plus pi equal to 0, so S equal to minus pi. Then for poles here, what is there? This equal to 0, 1 minus e power pi into Z inverse equal to 0, Z equal to 0 minus pi into t. To take here. Now pi equal to minus pi equal to S, so I will write it to the power st. So Z equal to e power st. For no confusion, I have given here only S. I have eliminated I. So Z equal to e power st, so there will be no confusion. It will be very straightforward. Now you should remember that Z equal to e power st is a general relation, but you should remember Zi equal to e power sit means for a particular Si I will get 1 Zi. What does it mean? It also means that a poles locating in the analogous plane or analog domain, corresponding poles in Z domain is Zi. For each pole Si, I will get 1 pole Zi. Agreed? So generally this is the expression, but we should remember that holds. Now z equal to e power st, that means you are having this. Now again s equal to sigma plus ji, so I can write it to the power sigma 1 in I into t, or sigma 1 into t. Then z equal to e to the power sigma 1 into t, and magnitude angle of z equal to sigma 1 into t. Now if for left of s plane, this sigma I less than 0, sigma 1 less than 0. So if it is less than 0 means negative. So magnitude of z will be less than 1, because e equal to 2.7182818. So e to the power negative means it will be less than 0.
Yes. আর t টা কিছু ভ্যারি ও t টা কনস্ট্যান্ট থাকবে?
T may vary. T cannot be negative because sampling time. T is a sampling time, maybe 0.1 second, 0.2 second,
আচ্ছা
0.3 second
হ্যাঁ
like that.
হ্যাঁ
Got it? Therefore,
yes
if
sir.
sigma is negative, then this product is negative. And if this is negative means magnitude of z less than 1. Agreed? Now, if this is greater than 0, so e to the power sigma 1 into t, that will be greater than 1. Therefore, again you will see the left of s-plane pole that will be mapped within the unit circle, right of s-plane pole that will be mapped outside the unit circle, that again satisfies the basic theory of stability. Therefore, this transformation is valid and which is known as impulse invariant transform. So what I have said, that I have written in line, you can read, and I hope if no doubt you can do.
স্যার আর ওইটা করলেন না 1টা e to the power minus sigma e is equal to যদি 1 হয় mod z2.
That is trivial. For j omega axis, it will be equal to 0, e to the power 0 equal to 1.
হ্যাঁ
So this is trivial, na? Mane, this is by default.
yes sir.
That's why I have not written, that you can understand easily. But anyway, I should have written anyway, but anyway, I have written also here. See that. Sigma equal to 0, z equal to 1. আমি এখানে আর লিখিনি, কিন্তু আমি লাস্টে কনক্লুশনে লিখে দিয়েছি। মানে এটা আলাদা করে বোঝানোর মতো কিছু ছিল না, বুঝলে তো? বুঝতে পেরেছো? All right. Now take on one more thing, that if I have omega analog frequency radian per second and omega digital frequency radian per second, this is radian per second, this is radian per sample হবে এটা, ঠিক আছে? সেকেন্ড হবে না, স্যাম্পল লিখতে হবে, ঠিক আছে? Okay, now z equal to r into e power j omega, general relation, z equal to s equal to sigma plus j omega, z equal to e power st means z equal to r into e power j omega, this I am substituting here, and s I am substituting sigma plus j omega. Then if you compare this, then omega equal to omega into t. What does it mean? This is the digital frequency omega, this is analog frequency omega, this is the relationship. Therefore, if I find omega, omega equal to capital omega, that is equal to small omega by t. So this is the relation between analog and digital frequency. Now this omega I am writing 2 pi f a, that is f analog, 2 pi f digital into t divided by t. So f digital equal to f analog by t. In other words, that f digital
analog into t.
F analog into t. So f digital equal to f analog by fs. T equal to 1 by fs. T is essentially sampling time. So reciprocal of this will be sampling frequency, and sampling frequency or fs. So digital frequency is nothing but analog frequency by sampling
frequency.
Now in your
small s and a capital.
Huh?
Small s and a capital s থাকবে।
ওটা ক্যাপিটাল এস লিখবো, স্যাম্পলিং ফ্রিকোয়েন্সি আমি ক্যাপিটাল এস লিখবো, মানে যেটা লিখবো একবারই লিখবো, সব জায়গায় এক লিখতে হবে, মানে এক এক জায়গায় একরকম না লিখলে হবে, ঠিক আছে? আচ্ছা, এবার যেটা আমার বক্তব্য, যে ইন এফআইআর ফিল্টার ডিজাইন digital cutoff frequency is given many places, that I have given 4 problems, all are with digital cutoff frequency. I have solved 4 problems in a FIR filter design. But instead of digital cutoff frequency, question may be given that analog cutoff frequency is given and sampling frequency given. So you can find digital frequency by dividing analog cutoff frequency with this sampling frequency. With that, you can get digital cutoff frequency. That modification I didn't mention over there because the relationship I didn't derive over there. So such kind of modification you can expect in the FIR filter design. What I mean, that directly digital cutoff frequency may not be given. Instead of that, analog cutoff frequency may be given and sampling frequency may be given. From the knowledge, from the given data, analog frequency and sampling frequency, you can find the digital cutoff frequency. All right.
Yes, sir.
Very good.
আজকে যেটা নোটটা একটু বুঝিয়ে দেবেন, আমাদের নেট প্রবলেম।
আজকে
যেটা প্রথমে করা
পরেরটা আজকে টাইম নেই মনে হচ্ছে, দেখছি দেবো। এইটা আজকে এটা পড়ালাম,
হ্যাঁ স্যার।
এটা কে আর কালকেরটা বুঝেছো?
স্যার
আচ্ছা, তাহলে দেখো আবার দেখেন, আবার বলে দিই, চট করে বলছি, বেশিক্ষণ সময় নাই কিন্তু। হ্যাঁ, ওকে, S equal to sigma plus j omega in general, if sigma equal to 0, S equal to j omega, বুঝতে পারলে অনুষ্কা?
হ্যাঁ স্যার।
ভেরি গুড। নাও magnitude of z equal to 1, magnitude of z equal to 1 কখন? when sigma equal to 0, মনে আছে? এই নোটটাতে পড়িয়েছিলাম, দেখো এই নোটটাতে পড়িয়েছিলাম, এই নোটটাতে পড়িয়েছিলাম, দেখবে যে magnitude of z sigma equal to 0, magnitude of zi equal to 1. Okay, that we have discussed in last class. Okay, so z equal to 1 when s equal to j omega, sigma equal to 0, so z equal to e power j omega, so s equal to 2 by t 1 minus z inverse into this. Now z equal to যদি e power j omega হয়, তো z inverse equal e power minus j omega, this is e power minus j omega. If you substitute here, because z equal to e power j omega, z inverse e power minus j omega, if you substitute here, then this will be like this, then this will be e power minus j omega by 2 if you common, e power j omega 2 minus e power minus j omega by 2, এখানে e power minus j omega 2 by 2 নিলে e power j omega 2 plus e power minus j omega by 2, then if you simplify you will get j omega equal to j 2 by t tan omega by 2. Okay, অনুষ্কা বোঝা গেল? আচ্ছা, এবার এখানে যদি ইমাজিনারি পার্ট if you equate, you will get omega equal to 2 by tan omega by 2. Then if you can simplify, you can check it here. Then if you simplify, you will find omega equal to 2 tan inverse omega t by 2. This is the relation of digital and analog frequency that you have derived here. So the way I have derived, I hope you understood the step. You check the mathematical calculation, it will be, you can understand, not an issue. Then I have said that analog frequency omega that can vary minus infinity to plus infinity. Okay, whereas digital frequency can vary up to minus pi to pi or 0 to 2 pi, because beyond that it will be repetition of the whatever thing present in minus pi to pi or 0 to 2 pi. Therefore this is a repetition. So if omega equal to minus infinity, if omega equal to minus infinity, that will be omega, capital omega equal to minus infinity, small omega equal to minus pi, in capital omega equal to plus infinity, small omega equal to plus pi. This is because if it is minus infinity, so tan inverse minus infinity, that will be equal to minus pi by 2. Minus pi by 2 multiplied by 2, that will become minus pi. Agreed? And omega equal to infinity means tan inverse infinity. Tan inverse infinity means pi by 2. Pi by 2 if you multiply it by 2, that will be equal to pi. Therefore, over the entire range of analog frequency, minus infinity to plus infinity, digital frequency will be mapped into minus pi to pi. বোঝা গেল?
হ্যাঁ স্যার।
Very good. Now with this, if we have this relationship like z equal to this, if this is given, then how could you find hs? This was the question. So what I have to do, you have to substitute s equal to this here, and then you have to calculate, simplify. So substitute s equal to this, then you have to simplify, and then finally substitute the sampling time 1 second. So what I have done, so we have to just substitute this, then we have made the calculation, then in this step t equal to 1 second, this is the answer, right? So this is hj. So this is the procedure by which you can convert s function into a z function using bilinear transformation. Agreed? So this is, তাহলে পুরো জিনিসটা আমার সামারাইজ করা হয়ে গেল, পড়ানো হয়ে গেল। তোমাদের কোনো ডাউট থাকলে বলো, otherwise I have to close today's session. If you have any doubt, you can ask, otherwise all right. Who are you attending? Rajni, Nupur, Kyapal, Oniket, Amit Kumar Nandi, Sanjana Mukherjee, Anudatta, Anushka Banerjee, Nitesh Kumar, Oritriya. Okay, ঠিক আছে. So anybody having any doubt, you can ask, otherwise I would like to close the session. No doubt আছে? No doubts.
স্যার এক্সাম নোটিশ এসছে স্যার,
হ্যাঁ বলো বলো।
স্যার আমাদের
এক্সামের এখনো কোনো খবর আসেনি, খবর আসলে জানাবো আমরা, ঠিক আছে? ওকে, তো শোনো, তোমাদের যেটা হয়ে গেল আইআর ফিল্টার ডিজাইন, আইআর ফিল্টার ডিজাইন পার্টে তোমাদের ট্রান্সফরমেশন গুলো হয়ে গেল, অ্যানালগ ফ্রিকোয়েন্সি থেকে ডিজিটাল ফ্রিকোয়েন্সি ট্রান্সফরমেশন হয়ে গেল। সো নেক্সট ক্লাস, whenever I will be there, I will be discussing, next class we will be discussing analog filter design techniques. Then we will apply these techniques to convert analog filter into digital filter. So next class, what is the date today?
নেক্সট ক্লাস
25
টুডে 25।
আচ্ছা নেক্সট ক্লাসটা আমি এই সপ্তাহে নেব না, নেক্সট উইকে নেব, ঠিক আছে?
হ্যাঁ ওয়েডনেসডে।
নেক্সট উইকে ওয়েডনেসডে অথবা থার্সডে তোমাদের আগে ফোন করে জানিয়ে দেবো, ঠিক আছে? আর আমি আজকের এই যে নোটটা আছে ওই এক নোটটা পাঠিয়ে দিচ্ছি,
ঠিক আছে
ঠিক আছে? নেক্সট ক্লাসে আমি নেক্সট উইক নেবো, ওয়েডনেসডে বা থার্সডে, ঠিক আছে?
ওকে
ওকে, আনটিল দেন থ্যাংক ইউ ভেরি মাচ।
ঠিক আছে স্যার
থ্যাংক ইউ স্যার।
হুম
থ্যাংক ইউ স্যার
হুম